Okay, hi everyone. So, good morning. Can I just do a short sound check just to make sure that you guys can hear me? Can hear me? Can hear me? Please let me know in the live chat so that I can begin. I hope that you have gotten the exercise that I sent in the group. Uh, yeah, it'd be a good idea to print it out if you can, but if you can't, then it's okay. Just use your phone or your device or whatever to open the PDF lah. Okay. All right. So let's begin. So today, what I want to do is I want to discuss lah. Okay, I want to discuss a few example questions because I realized that in doing electronics, actually, of all the chapters, electronics is the easiest um, because uh, you don't really have to go into that much detail when you come to explaining things. And if you answer enough questions from electronics, you realize that actually it's not that confusing lah. Okay, so that's the reason why I wanted to do this today. Next week we will finish the chapter and our entire syllabus together. Ooh, finish already. Okay, so let's begin. Let's take a look at the questions. But before we begin, actually, I want to start off by talking about this. So this was your previous exercise. Okay, this was your previous exercise, and a lot of you had problems with this question lah. Oh, sorry. A lot of you had problems with this question. Calculate the velocity of the cathode ray in a multi-source tube. Okay. Now, one very important thing to remember is that uh, this velocity thing, yes, there is no specific formula lah. Bukan macam bab 2. Okay, velocity is displacement over time. Okay, so we are always very stuck with this. But we have to be a little bit more open-minded to know that everything in physics is about change of energy. So it shouldn't surprise us when we hear the word velocity, okay, in the topic of electronics. Okay, but maybe some of you have forgotten, so that's why I want to mention this lah. Okay, that there is a change of energy that happens here, which causes the electrons to move very fast. Okay, and of course, the moving very fast is this 3 kilovolts lah. Okay, so the formula actually is the charge of one electron times the voltage that you apply equals to 1 over 2 mv squared. So this is kinetic energy. Okay, and this is electrical energy. Okay, this one I mentioned very briefly lah. Actually, I mentioned very briefly, so that's why I thought, okay, I better mention again in case you get this question this year. Okay, so EV, E is the charge of one electron, which is this. Okay, and then V is the voltage of the extra high voltage. Sebab inilah voltage yang menyebabkan pecutan. Okay, this is the voltage that causes the higher velocity. So you cannot take this 6. This 6 cannot. 6 is untuk menghasilkan elektron sahaja. Okay, just enough energy for the electrons to free themselves so that they will be emitted. Okay, but the one that causes the velocity, the one that causes the high velocity is this extra high tension. Okay, the EHT lah. Okay, or the voltage lampau tinggi, 3 kilovolts. So over here we have 1.6 times 10 to the power negative 19 times 3000. Okay, equals to half. Then the charge of, the mass of one electron is this, then you can find V squared. This formula, by now, you should know what this formula is. This is the formula for kinetic energy. Okay, half mv squared. Ini saja yang mungkin kau lupa. So I purposely wanted to mention this so that you don't forget. Okay, it's very simple. EV, electrical energy is EV. Of course, there are many formulas for electrical energy. Okay, in terms of power pun ada, in terms of V and then R or V and then I. Okay, there are many formulas for electrical energy, but the one that we use usually for multi-cross tube or for thermionic emission is this one. Okay, E times the big V. Okay, the voltage that is extra high tension lah. Okay, so I just want to mention this here so that you guys realize that, oh okay, di sini pula kita ada guna benda ni. Okay. All right, next one. So let's start by talking about the exercise. These exercises are diode, and then mostly transistor exercises lah. Okay, so after I discuss these few examples with you, I'm going to give you another set of questions for you to do as your homework. Okay, obviously the questions are not same as this, but the reason why I discuss these questions today is so that, okay, you have an idea of how to answer the exercise questions that I'm going to give you. Okay, so let's begin now. Question number 1. Diagram 1.1, 1.2. Show two circuits with identical components. So let's identify the components. This is the battery, this is the light bulb, and this is the unknown component, obviously lah. Okay, and over here there's a missing one. Actually, this should be X. Okay, name the electric component X. Okay, so triangle with a palang at the side. So this is obviously a diode. Okay. Now, explain why bulb in diagram 1.1 is light up. Kenapa sini light up and kenapa sini is not light up? Okay, so let's take this as a revision lah. Now, the only reason why it will light up and not light up is because of the way the diode is connected to the battery. Okay, and there are two types of connections, which is the forward bias. Oh, sorry, no E. And the other one is reverse bias. Okay, so we know that if it is forward bias, the positive is connected to this is the which junction? This is the P junction, this is the N junction. Okay, this is the P diode, this is the N semiconductor, and this is the P semiconductor. Okay, so if positive is connected to P, then it's forward bias. If positive is connected to N, then it's reverse bias. And we know that if anything is connected in reverse bias, electricity doesn't flow, current doesn't flow. Okay, so 2 marks. 2 marks is because we need to mention that 1.1, okay, is forward bias. Okay, and 1.2 is reverse bias. Okay, this should give you 1 mark each lah. You should just mention that 1.1, the connection of 1.1 is forward bias. The connection of 1.2 is reverse bias. Okay, if you really want to be like, if you really want to fill up all 3 lines, okay, in this one, then you should just say lah, 1.1 is forward bias, so current flows through the diode. Okay, and then 1.2 reverse bias, okay, current does not flow through the diode. Okay, dot. Okay, that one is a really lengkap answer lah. Okay, like super lengkap. But as you know, if you just want the basic answer, you just need to mention that 1.1 is forward bias, 1.2 is reverse bias. That should be enough. Okay, all right. Diagram 1.3 contains 4 identical electronic components to charge AC to DC. Okay, how and let's talk about this. Sorry, not charge, change. Okay, sorry, changing AC to DC is a process called rectification. Okay, so that's why I say this exercise kan semua untuk ulang kaji saja ni. Rectification, changing AC to DC is called rectification. Okay, using electronic components. Kalau kita cakap pasal you know what, I'm not going to confuse that. Let's just leave it as it is. Okay, so your supply is an AC supply, alternating current supply, and then bila keluarkan dia akan keluar sebagai DC. Okay, so this is, and there are two types of rectification lah. Okay, one is half wave rectification, and the other one is full wave rectification. Okay, now in the case of these 4 components over here, okay, this is obviously full wave lah. Kalau half wave kan is just 1 diode only. Okay, kalau full wave is 4 diodes. Okay, but the thing that everybody always tends to forget is how the diodes are arranged. Dia bukan main simply kau campak je macam mana itu diode. No, there's a way to arrange it. Okay, so of course, in the question 1 over here, on diagram 1.3, draw the electric components in the circle provided. So you have to draw 4 diodes, but the arrangement is very important. The direction in which they are arranged is very important. Okay, so the direction will be like this lah. Triangle here, and this one is another triangle. Okay, so I like to think of it is like this lah. Begini dan begini. Okay, that makes it very easy for me to remember. So, triangle. This is the palang, and here is another triangle, and this is the palang. Okay, so starting point, ending point. Okay, one direction, one direction. Okay, please remember this. Okay, I'm saying this a lot of times. Yes, it's not going to come out during your trial exam. Don't worry. Okay, it will come out during your trial exam, but it is always good to remember this. Okay, because SPM, this question hasn't come out for quite some time. So I'm thinking, maybe a good idea to know this lah. Okay, so remember the arrangement of the diodes. Now draw the wave of the full wave rectification. Now, as I said, two types of rectification. One is half wave, one is full wave. But I'm just going to draw all three lah. So the answer for this, okay, the answer for this is this lah. Okay, this is full wave rectification. Okay, and it's very simple. Don't even need to label the axis as long as you can draw this. So this is full wave rectification. Now, what if it is half wave rectification? Okay, I'm going to change the pen. If it is half wave, okay, it is positive 0, positive 0. Okay, this is half wave. Okay, now in our previous lesson, I gave you a question and I said that, and a lot of you gave me the third one, which is this. You gave me full wave, tetapi ada flat. Like that. Okay, now this one is full wave with capacitor. Okay, so this is half wave, one diode only. This is full wave, 4 diodes. This is full wave with capacitor. Okay, now how do you know when to draw this and when to draw this? You need to look at the circuit. Okay, this is not a capacitor. This is a resistor. Okay, the symbol for capacitor is like battery, except that the lines are the same length. This is a symbol for capacitor. If you see this, sign together with this full wave rectification circuit, then this is the graph that you need to draw, blue color. Okay, and usually, where is it located? Okay, usually where is it located? It will be usually parallel to the resistor, or parallel to, usually it will be here, like this. Okay, if you see this, then this is the graph you draw. But because in our question now, we don't see the capacitor, we only see a resistor, okay, then we draw this red color. Okay, so please know the difference between all three. Okay, if you want to know what a half wave circuit is like, just remember it's just one diode, one resistor. Okay, so I hope that this clarifies things lah. Okay, and it's good for us to also ulang kaji. Let me just check if there's any questions from anybody. Nobody, no questions. All right, good. We have 22 people on the screen at this moment, so I wonder where the other 7 are. But let's go on to the next question. Oh, sorry. Name one electrical component that can be used to smoothen the current. Okay, smoothen the current. So this one is capacitor. Okay. Now the reason why I say that electronics is very easy, right? Because there is very little things that we can ask. Okay. Actually, in the field of electronics, is very besar lah. Okay, it's very besar, and there's actually a lot more explanation than setakat apa yang kamu ada. Okay, which is a problem for people who are setting questions. Okay, like if I'm a question setter, it's a problem for me because I cannot really ask that much. Ini saja saya boleh tanya ni kalau pasal full wave rectification. That's as much as I can change. I can maybe add a capacitor. Okay lah, change the full wave lah, or there's nothing really much to rectification. That's why you should remember this because it's sangat sikit untuk kamu ingat lah. Okay, dan dia sangat senang untuk difahami. Okay, you don't even actually have to explain I pray to God not lah. You don't actually have to explain this one. Paling pun lah. Okay, paling pun. You may have, there is a question that came up before. I think it's in your SBP book. Dia suruh kamu tanda the anak panah of the perjalanan of the current flow. That's all that's probably the most difficult lah. But other than that kan, many years this question came out already. Okay, and most of the years also is very same one. Okay, ask you to draw a wave diagram and then ask you to add one electric component. Itu saja. Okay, so we should try to remember this subtopic lah, because it's very easy. Seriously. Okay. All right. Let's go to the next question. Now this is transistor lah. Okay, transistor. So let's go right into the question. Okay. We just to ulang kaji ya. Remember, this is the base circuit. This is the collector circuit. Okay, and there is only one formula that is involved, which is IE, the emitting current, equals to IB plus IC, di mana IE flows out here. Okay, sampai ke junction ini saja. After that, it goes, this will be IC, and then over here will be IB. Okay, but yeah, we just want to know this. So, A, name the type of transistor used. There are two types of transistor, which is the NPN transistor and the PNP transistor. And how do you differentiate between these two transistors? Is this arrow sign. Okay, kalau arrow dia ke bawah, there is NPN. Kalau arrow dia ke atas, okay, begini is PNP. So this is NPN transistor. Okay, some books they like to write like this NPN, mengada-ngada lah, tapi boleh juga lah. Okay, so I don't want also can one lah ya. Okay, mau juga ada dot. Okay, so observe diagram 1.1. State the function of the transistor in the circuit. Now, there are two functions of transistors. Okay, if you remember what they are, because I just told you to draw the diagram, right? There are only two functions. They are either a switch or amplifier. Okay, two functions saja. Transistor sebagai switch atau transistor sebagai amplifier. Okay, so in this circuit, it's very obvious that it is an amplifier because tengok, sini 12 milliamp, sini adalah 76 milliamp. So the current is amplified. So the function of the transistor is as a current amplifier. Okay, now when we study this, when we talked about this in the last lesson, there are two types of amplifiers lah. You either amplify the current or you amplify the sound. Okay, and the sound amplifier circuit is different. But it's very easy to know whether it's a sound amplifier or current amplifier. Kalau sound amplifier kan, mesti ada satu komponen di sini, which is the speaker. Okay, and it's very easy because, speaker means sound lah. Takkanlah speaker itu current kan. Okay, so it's very easy. Switch yang susah. Okay, because there are two types of switches. Okay, one is a light switch, one is a heat switch. Okay, light is LDR, heat is thermistor. Ini kena ingat lah dia punya komponen. Okay, so we will come to that in a while lah. Okay, calculate the value of the emitting current IE. Okay, this is very simple. I give you the formula here. IE equals to IB plus IC. IB is 12. Okay, plus 76 milliamps. Okay, make sure that the unit is the same lah. Okay, sometimes this can be microamp, this can be milliamp. Okay, what happens if this is microamp and this is milliamp? You make sure you change it to ampere. Okay, just to be safe. Okay, but in this case it's a very simple 1 mark question, 2 mark question lah. Okay, satu markah untuk ganti dengan betul, satu markah untuk jawapan akhir yang betul. 88 milliamps. Okay, that's it. Of course, dengan unit yang betul lah. Kalau kau bagi saya 88 tanpa apa-apa, it means nothing to me. Okay. Now, a transistor circuit can also be used as an automatic switch. Ta-da-da. Now, using the symbol of the variable resistor X, this one, and the resistor R shown below, complete the transistor circuit in diagram 1.2 so that the LED will automatically light up in the dark. Okay, this is very important now. Okay, because that's why I told you to do this exercise the other day. You need to know the difference between the circuit now, where the LDR is placed, sorry, where the variable resistor is placed, if we want the light to light up in the dark or if we want the light to light up in the day. Okay, although it doesn't make sense, okay, but sometimes we want that to happen. Terang-terang macam ni pun kita mau lampu hidup. Okay, don't know why, but some people like it that way. So we must be very sure about this. Okay, and we know that where the variable resistor is, okay, the other resistor yang permanent itu dia akan berada di sebelah lagi lah. Okay, so where? Tell me where. Is it down or up? Kalau in the kalau in the this one. Tell me. Is it down or up? Down or up? Sorry, waiting for response is always like taking forever. Where should my LDR be? Sorry, this variable resistor juga dikenali sebagai LDR lah, light dependent resistor. This is permanent resistor. So where should my this one be? Okay, it should be up. Really up? Up. Okay, so up over here, so you just draw over here, circle, and make sure you put the two arrows. And then this will be the permanent resistor. Okay, so the name the variable resistor is LDR, tapi just to be safe, guys, because they say name, we usually don't write the short form. Okay, we usually write light dependent resistor. Okay, so we usually, let's write it that way lah. Now, see, some people say up, some people say down. Now, which one? I'm just following you all only know because you all already drew the circuit. LDR should be where? Down or up? Okay, important thing to remember is LDR. Okay, resistance naik bila dark or bright? Okay, resistance naik bila dark or bright? That's why. Okay, so actually it should be down. Okay, because we want it to light up in the dark. Okay, it should be down here. Okay, LDR should be here, resistor should be here. Okay, because okay, how the circuit functions, we need to remember that ini ciri LDR yang sangat penting. When it is dark, okay, the resistance will naik, the resistance of the LDR will increase. So because the resistance of the LDR will increase, the voltage that is supplied to the resistor will increase. Therefore, the base current will switch the transistor on. Okay, sorry. In your explanation, most of your explanations, you don't actually say switch transistor on. The IB will flow and cause the IC, we'll switch the transistor on and then IC will flow. Collector current will flow lah. Okay, and the LED will light up. Okay, ingat sini mesti ada cukup current, baru sini akan mengalir. Okay, and in order for this to have enough current, there must be higher voltage over here lah. Okay, and in order to have higher voltage over here, you need to have higher resistance. Okay, so that flow is always there. Resistance tinggi, voltage tinggi, base current will switch the transistor on, IC will flow. Resistor high, voltage. So the only thing you have to remember is which situation is resistor high. Okay, so for LDR is when it's dark. But you also have to remember which situation you want the LED to light up. So in the dark means the resistance must be down there. The LDR must be at the down. Okay, at the down pula. See lah? That's fine. Okay, so explain how the circuit functions. Actually, you've done the exercise, so I'm just giving the basic apa tu the flow over here lah. Okay, but don't forget this. All right. Now let's talk about this. Oh, it's a new question to now. The door of a lift is fitted with a light transmitter. Okay, so it's a light transmitter and a detector, which is a light dependent resistor here. Okay, so there is a light over here. Okay, yeah, sorry, all these labels here, like don't know why terlari sudah lah. Okay, but this is the labels lah. R2, R1. This R2, R1 also important, but this 240 here is the motor. Okay, this is a relay switch. All right. So if the light dependent resistor detects light, the relay switch is activated and the lift door will close. Okay, the diagram 2.1 shows the electronic circuit for the control system of the lift door. The question is, what is the function of the transistor? Okay, as I said just now, there are only two functions of the transistor. It's either as a switch or it's either as a current amplifier. And in this case, because dia akan menghidupkan satu lagi benda kan, so the function will be a switch. Okay, function of a transistor is a switch. That's why I said transistor very easy, you know. Okay, two functions sahaja. Don't have to think about the other function. Okay, why is a relay switch needed in the circuit? Okay, so why is this relay needed in the circuit? Okay, sometimes you will see. Okay, sorry, I'm going to extend this over here. Sometimes you will see different circuits kan. Then tiba-tiba kan ada satu lagi cabang di luar di sini. Okay, and over here baru is the mentol. Okay, so this over here is connected to this one. Yeah, and it is connected using this thing called a relay switch lah. Okay, and if you actually see in our house kan, actually got a lot of relay switches. Okay, if you want to know what's a relay switch, please go and Google the picture lah. Then you say, oh, benda ni relay switch pula kan. Okay, so please take note of that. But the reason why I wanted to discuss this question is to talk about this lah, because this is also a popular question. What is the function of the relay switch? Why do you need a relay switch in the circuit? Now, I only mentioned the relay very briefly in chapter 3. Okay, and I purposely waited until chapter 4 to talk about the relay. So in chapter 3, when we study electromagnetism, actually this is a relay switch. Okay, and I want to talk about this section only lah. Electromagnetic relay or relay switch is used as a switch that uses the small current to switch on or switch off another circuit that uses a large current. Okay, so dia menggunakan arus yang kecil untuk menghidupkan atau mematikan satu litar yang menggunakan arus yang besar. Okay, I repeat the function of a relay switch, okay, is to use a small current to switch on or switch off another circuit that uses a large current. Okay, so in this case, why is a relay switch needed in the circuit? Okay, is basically that function to switch on the circuit which uses a larger current. Okay, this one, to switch on the circuit which uses a larger current. We know that in the base circuit over here, okay, the current is small. In the collector circuit of a transistor, the current is big. Okay, but you see the thing about the relay is we use the relay essentially okay, uses this small current to enable you to switch on this big current. Okay, and at the same time, it also keeps this motor over here safe. Okay, and it is an extra precaution lah. Sini kena on, baru sini ini. So you want to avoid possible short circuit or possible overflow of. Sorry, I'm looking at. Sorry, possible overflow of current. Okay, it's just to keep this motor a little bit safer lah. Daripada kau terus direct sambung. Okay, because we're no longer talking about milliampere, talking about amperes and amperes lah. Okay, so I repeat, the function of the relay switch, why we need a relay switch, okay, the most important function of the relay switch is to use a small current to switch on the circuit with a bigger current. Okay, that's the official one lah. Okay, And I will leave it at that. I think that's a better answer. Okay, to use a small current to switch on the circuit with a bigger current, okay, which is at the collector circuit. Okay, diagram 2.2 shows a simple automatic circuit switched on a bulb during nighttime at the porch of a house. The resistance R2, sorry, I should be doing this. Okay, the resistance R2 is 600 ohms. Okay, so over here is 600 ohms. Am I getting this right? Correct. Okay, 600 ohms. Now the bulb is switched on when the base voltage VB is at least 1.5 V. Now this is a very important thing. Okay, bulb akan terhidup sekiranya over here, okay, is 1.5 V. Okay, and that's the reason now. So ini akan hidup. Ting, 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 ting. Okay, hidup. Itu. Sorry, I'm looking at the kitchen because my dog is doing something and I don't know what she's doing. Okay, so the first question is, if the bulb lights up, what is the maximum potential difference? Okay, what is the maximum potential difference across R2? Remember, potential difference is also known as the voltage. Okay, so let's look at this condition. Dia cakap bulb will be switched on when the base voltage is 1.5. Okay, so what is the maximum potential difference? This is a no-brainer. Kalau sini 1.5, the whole potential difference over here is 6 volts. Okay, and we know that the function of this is called a potential divider. Okay, no matter what happens, the potential in these two resistors is always divided and must be equal to 6 because maximum is 6. So if here is 1.5, here will be 6 minus 1.5 will be just 4.5. Okay, that's this one. That's how the potential divider works. It just divides the potential. Okay, what if it is, okay, what if over here, okay, is 1 volt? Okay, if over here is 1 volt, the mantle will not light up lah, obviously, because ini syaratnya. The base voltage must be at least 1.5 volts. Baru dia akan hidup. Okay, but does that mean that there is no resistance here? No, sorry, there is no potential difference here. There is. Okay, and the potential difference will be 5 volts. Okay, but unfortunately, the bulb will not switch on. Okay, what if over here is 4 volts? Okay, if over here is 4 volts, will the bulb switch on? Yes, it will switch on because sudah melebihi 1.5. And how much voltage is running through here? It will be 2 volts. Okay, so this is the beauty of this potential divider. Okay, it's very simple. You just need to know that the total is 6 and itu saja. Okay, so I'm going back to the question. So here is 1.5 volts. Apa ini? Okay, and because of that, this is 4.5. Sebab 4.5 plus 1.5 equals to 6. Okay, the potential difference is the same. Sama jauh lah. Okay, so what is the maximum potential difference across R? This will be 4.5 volts. Now calculate the resistance of the LDR when the bulb is light up. Okay, now this one, we have to go back to this formula that we learned in the... Sorry, where's the question? Oh, I must have deleted the question. Okay, potential divider. Okay, potential divider is R equals to V1. Oh, sorry. Sorry. My bad. Not R. It should be... Okay, it should be V equals to R1 over R1 plus R2, or V1 now, okay, times the maximum voltage. Okay, so in our case here, the resistance of the LDR, since we want to calculate the resistance of the LDR, so 1 refers to everything that has to do with the LDR. So what is the voltage in the LDR? Is 1.5. Okay, so this will be 1.5 equals to the resistance of the LDR over the resistance of the LDR plus, how much is this R2? 600. Okay, 600 times the maximum voltage is 6. Begini. Okay, we did this formula in the previous class lah. Okay, so please calculate R1 for me now. Okay, calculate R1 for me now. I'm going to take a short 3-minute break. I want you to calculate this and then give me your answers in the live chat. Okay, I will be right back. Okay, hi everyone. So, all right, the answer is 200 ohms according to this calculation lah. Okay, but I want you to consider something very strange. Okay, I want you to consider something very strange lah. I'm not saying that the answer is wrong. Answer is correct. Okay, it's 200 ohms lah. Okay, after you calculate, then you get 200 ohms. Okay, but I want you to consider something a little bit strange about this question lah. Can you see what's strange about this question? I'm just wondering if you can notice it lah. Okay, now we have learned that in the dark during night time lah. Okay, this resistance is supposed to increase. Okay, the resistance of the LDR is supposed to increase. So if the resistance increase, by right now over here should have a bigger voltage compared to up here lah. Right? There should be more. There should be more over here. Okay, but if you notice our calculation, all the numbers doesn't make sense one. Over here is 600, but over here kan bila kau kirakan dia 200 saja. Okay, because the condition is 1.5 volts. Okay, it's a very strange question. Okay, and when I was doing this question, I was like, should I explain this? Because it really doesn't make sense. We should, because all the time when we do explanation, kan kita cakap, oh, okay, in the dark, resistance increase. Kalau resistance increase, voltage will increase, IB will flow, yada, 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 yada. Okay, but the problem is they already give this syarat over here, at least 1.5 volts. Okay, dia sudah memberikan syarat lampu akan hidup kalau at least 1.5 volts. I'm like, okay, tapi tidak apalah. Okay, sometimes I guess maybe people who set questions, they tend to forget this because this question is basically all about how to use this formula, okay, for calculation. But I just want to mention, if you can understand what I'm saying, then, good lah. If you can't, then it's okay. Just anggap saya sebagai kurang waras lah. Don't know what I'm saying. Okay, never mind. But question number 3. A student wants to modify the circuit in diagram 2.2, okay, to become an automatic siren when the weather is cold. Okay, now suggest electrical components that needed to replace the LDR. Give a reason. Okay, so this one. Only one electrical component needed to replace the LDR. So the electrical component will be a thermistor. Okay, the thermistor. And why the thermistor? Because the resistance increases when? The resistance of the thermistor increases when? Bila dia panaskan, bila dia sejuk. Okay, the resistance increases when it is cold. Okay, so you put the thermistor over here and you change this with a siren now, obviously. Okay, ini sepatutnya tukar pergi speaker. Okay, or siren or alarm. So that when it is cold, then the thermistor over here will be high resistance. High resistance, high voltage, IB will flow and switch on IC will flow and siren will berbunyi. Okay, so, but this is it lah. Now, this is also very commonly asked, but usually they won't suggest one electrical component, usually they will suggest two electrical components. Okay, so the first one is change the LDR to become a thermistor. Okay, second one is change the bulb to become a alarm. Okay, or siren. Okay, usually is that lah. And this one is also commonly asked in 10-mark question. Mau mengubah suai. Okay, so tolong ketahui ini. Okay, just to recap, symbol for thermistor, kalau LDR, thermistor, all resistance the same lah. Cuma LDR dia adalah dua cahaya and one circle. This is LDR. But thermistor is the same thing over here, okay, except that you have one very strange, apa ini? Sorry, I terlampau over sudah. It should be, something like this. Macam tu. Okay, thermistor, if I'm not mistaken. Oh, no, sorry. Ayah. Inilah kalau orang tua ni. Sorry. My mistake. It should be like that. Yeah. Okay, something like that lah. Okay, thermistor, gorintang peka haba. Apa ini? Sejuk panas. Why sejuk panas? Okay, no. Okay, last question I think. Should be the last question. Okay, diagram shows two situations of electronic circuit. Da-da-da. Okay, when it is light, da-da-da. No, this one. When it is dark, da-da-da. The bulb lights up. Okay, so obviously this is the same question as the one before this lah. Okay, so compare the resistance of component X in these two situations. Okay, so diagram 3.1, diagram 3.2. Okay, the one with the the one with the menthol light up obviously has a higher resistance lah. Okay, so this will be 3.1 is less than 3.2. Okay, 3.2 must have the higher resistance. Compare the potential difference across component X. Potential difference always follows resistance. So 3.1 is less than 3.2. Kan? Okay. State the relationship between the resistance and the potential difference. Okay. Remember, when you talk about relationship, mesti kamu ingat mana yang mempengaruhi, mana yang dipengaruhi. Okay, very important. Bukan kau main letak saja macam tu. So in this case, is the resistance depending on the potential difference or the potential difference depending on the resistance? Okay, it is the potential difference depending on the resistance. So the higher the resistance, the higher the potential difference. Okay, that's the relationship. Because yang menyebabkan the voltage tinggi atau rendah is the rintangan. Okay, the rintangan yang disebabkan oleh ada cahaya dan tiada cahaya lah. Okay, name the component X involved. This one we've already done this. This is in LDR, but please give full name. Okay, don't give short form. Okay, give one application of a transistor. Banyak ni. Transistor sebagai, banyak lah. Okay, but in this case, okay, this will be a light. Sorry, apa ini? Okay, light operated switch. Okay, or heat operated switch. What is another application of transistor? Sound amplifier. Okay, I hope that by now you notice that transistor questions kan itu saja itu. There's really nothing much I can ask. Okay, so it's actually pretty simple lah. Alright, is this the last page? Yeah, okay. So the resistance of R1 is increased in diagram 3.2. So we increase this resistance. Okay, so what is the meaning of resistance? Suddenly they ask this question now. Okay, resistance is, siapa ingat? Who remembers the definition for resistance? It's okay, resistance is actually chapter 2, ratio of voltage to current. Okay, R equals to V over I. Okay, this is from Ohm's law lah. The ratio of voltage to current is actually the resistance. So what happens to the brightness of the bulb? If we increase the resistance over here, okay, in this circuit, apa yang akan terjadi over here? If you increase this resistance, this potential lebih banyak V akan berada di sini. Lebih banyak V means sini akan berkurangan V. Okay, mungkin mentol masih menyala, tetapi dia akan berkurang. Okay, so the brightness of the bulb will decrease. Okay, the brightness of the bulb will decrease, and the reason for this is potential difference in the LDR has decreased. Okay, atau you can also say the resistance. No, sorry, not the resistance. The resistance is the same. It's just that the potential difference in LDR decrease, or the other one is current flow in base circuit. Okay, decrease. Either one of these lah. Okay, I would prefer the first one lah. Potential difference in LDR decrease. So itu yang permulanya. Potential decrease, then the current flow decrease. Mungkin dia masih mencukupi syarat for it to switch on the transistor, but it's like just there lah, sana-sana saja. So not really full brightness. Okay, because the resistance has increased. Okay, so I hope this helps you. I hope today's session has helped you to know that, okay, actually transistor is not as difficult as you think it is. The only difficult part is remembering the circuit. Okay, actually lah. Okay, remembering the circuit is important. Okay, so I'm going to, you know what? Your assignment for today has been posted up, or is going to be posted up in Google Classroom soon. Okay, so go and check your Google Classroom, and then please finish the homework by this Sunday. Okay, I have given you 3 questions, paper 2 questions lah. Okay, that is essay. So please answer in foolscap paper, and as always, scan and submit your work in your Google Classroom. Okay, by this Sunday. Okay, so have a good weekend, everybody. I will see you next Monday. Take care.